Actually, this class is meant for yesterday, so it is a little bit delayed because content is not ready. Right now, I am taking. So yeah, we can start. First point. By default, local variables are stored in the stack area. By default, of course. By default, global variables are stored in the static area. That is also okay. Variables are declared with the static keywords are stored in the static area even if they are right local variables. Even though some local variables are there, but you declared as a you declared while declaration you kept static keyword, so they will go in the static area. So if you observe clearly here, static area is very small area fixed. Heap area and stack area, they can grow. These two are runtime they will store. This is compile time. This space is used to compile time, right? Static space is used to compile time, right? Heap area, stack area used running time. They will keep on shrinking like that, right? Next one, the local variables contain garbage value by default, because local variables are more local variables are more. Local variables contain garbage value by default. What is the reason? Local variables are more people we cannot initialize, so garbage. Global variable or static variable, because they both are there in the static area, which is very small area, right? You can clean. So global variable, static variable is initialized with value 0. Global variable and a static variable is initialized with value 0. Okay, fine, that's okay. Now let's come to next story. Let's come to next story. Two types of scoping. Careful everyone. Two types of scoping. Static scoping, dynamic scoping. What is the meaning of static scoping? If the local variable is not there, then the access of a right. If local variable is not there, you will access the global variable. That is the meaning of static scoping. What is the dynamic scoping? If the local variable is not there, then we will access the variable from where you came previously. Means, I think, isn't that from A function you went to the B function. In the B function you said print some x, not there. What dynamic scoping will do is, from which function you came, it is there in the stack, it will go there it will check x is exist or not. If your x is not there, so in the previous one x is there or not, right? So you will go back and you will check. Other than this, nothing is there. Dynamic scoping, currently not available, previously from where, at least they're available or not, so that is a static scoping. Dynamic scoping, everyone know. So I just given one example also. Let's check small. Let's check one small. Int a is equal to 5. So if you go inside, int a you give, so print a you said, right? Is a local declaration is there, so output will become garbage. All right, now next one. If you see this program, int a is equal to 5, right? Main program started. There is a main programming started. So inside, if you see static int a, static print a, because of the static 0. Because of the static 0. Everyone only for namesake, right? Only one time I have to read. I am reading. One time I am reading. So please go ahead one time. But remember, scope of a variable is important. Static scoping, dynamic scoping, and a static variable. Static variable also important. Scope of a variable, okay. Now static keyword also we are discussing static keyword also. Can we see one more? I think this program something related to extern, right? So let's see this one. Int a is equal to 5, right? Inside int main, extern int a, okay. Print a, remember is the external variable. External variable is a local variable, but memory taken which is there outside is there, that memory, right? So when you say print a, so global variable will be printed because it is taking the memory of global. Next one, a is equal to 25 you said, right? I think from which memory you are taken, that place only will change. Afterwards, print a, 25 will be printed external. It is not asked until now in the previous paper. It may come, so please careful. It may come, please be careful. Okay, fine. That is also okay. Remember, external will access the global variable. Extern will access the global variable. It is taking the memory of global. Even though it's a local, but you don't want to take the memory because you don't want to take memory again. You will take the memory of global variable. Now, let me see one more. Int A, register int A, auto int A, all three get space in the stack area as a local variable. Local variable only means meanings are different. Register means in the register. Int A means in the stack. Auto int A means automatically in the stack only. So output point of view, all three are same. I want to say this, right? Not stack area. See, all three get space, right? All three get space like in stack area. In the stack area, whatever happening, same thing. Register means a little faster. Other than this, nothing. All three will give same output. That is the meaning of this line, right? Don't go in the anything little bit wrong also. All three will give same answer. The only thing is register means faster. Int A, auto int A, same. Both are same. Memory created in the stack. Register memory will be created in the register. Right? Fine. Perfect. Now see one small example. Right? Very, very important. On the static variable, definitely you can expect one question. On static variable, definitely you can expect one question. Please be careful. It's a very, very important one. On static variable, definitely you can expect one question. Very, very important. Be careful. This will come in the exam somehow. In the classroom, we done many static variable. On the static variable, many problems we done. Right? In the GATE examination, definitely one static variable question will come. That is the reason in the class, we done so many problems. But I have given one sample here. Right? Only I think to say that it is important, I given one problem. Let's go here. Everyone see? Everyone's here. I think when you run this program, see f of 5. And one more thing is f of 5, so 5 is came. So let me write now f of int n. This is a local variable, so memory will create n value 5. Okay, go inside. Local variable, so n value 5, so go inside. Okay, static car, remember it is a static variable. Memory will create in the static area. R value initially 0. Right, next one. Static variable memory will allocate only one time. Everyone know. Static variable memory will allocate only one time. Only one time, please be careful. So one time I already created. Address may be 1000. But here address is 2000. Okay, fine. Until now, fine. Is n value less than or equal to 0? N value is how much? 5. 5 less than or equal to 0? No, fail. Go to the next one. N is greater than 3. N value is 5, which is greater than 3. Yes. Go inside. R is equal to n. N value 5, so 5. Next one inside. Return f of, right? N plus 2, n minus 2 plus 2. So return f of n minus 2. N value 5, 5 minus 2, 3. So n value 3 plus 2. So again, it is a function call, it will take care. Go inside. First line. Static int r is equal to, remember, static variable will be initialized only once. Memory also will create only once. Remember, this will be initialized only once. Memory also created only once. Okay, fine. So I think first line will skip. Let's go to the next one. N value 3. 3 less than or equal to 0? No. 3 greater than 3? Condition is fail. Let's go to last line. What is the last line? F of n minus 1. See this one. F of n minus 1. F of n value 3. 3 minus 1 means 2. So n value 2 plus r. Remember, don't write value. Plus r, you can write r only because r may update also. And one more thing, without completing this, how can you go here? Remember, even though I am writing these people, even though I am writing the right people, without completing left, how can you go to right? So please be careful. So you can avoid the right things. Best thing is you can avoid the right things. After coming back, we'll see. After coming back, these values we'll see. Whatever is there, we will take. Because without completing left, you cannot go to right. Right? Okay. F of 2, again come back. Static, skip it. N value 2 less than or equal to 0, fail. 2 greater than 3, fail. So same story. F of n minus 1. So n value 1 plus r. We'll see whenever we will come back at that time, whatever r is there, we'll take. But one thing, without completing left, how can you go to right? That is the reason. while using the static variable, please be careful. Static variable memory will be created only once. Initialization also only once. If you want, you can see R is only one time. But N is memory creating again and again. See, N here also memory will create. N here also memory will create. N here also. Everywhere N memory will allocate. Everywhere memory will allocate for N because N is not a static variable. R is a static variable. One time memory, one time initialization. And one more. Right? Because of one time memory, one time initialization, and so many function call, anyone can change it. If you use the static variable immediately, then you will get the whatever value there that time you will get. If you use after some time, right, I think it may update. So please be careful. I hope everyone fine. Static variable you may see in the exam. I'm saying very clearly, see, 99% it may come in the exam. Be careful. Static variable will come in the exam 99%. Not 98, not 95, 99 it may come. Right? Static variable and recursion. It's a very good combination. Static variable and recursion is a very good combination. Suppose assume, here if I say, see this one, here if I say print R could have printed 0. Here if you say print R could have been printed 0. But after some time if you print, updated values will come. Okay, fine. Static variable, please be careful. So I'm writing, if you want those points, I'm writing also. 1 point. Static variable, memory only one time. Memory once. 2. Static variable, initialization once. Static variable, initialization also once. Static variable, initialization also once. 3. Someone is saying, won't update R is equal to N for each iteration. Yes, it will update. Right? Update is different. They modify. Right? Update is different. Initialization is different. Starting whatever you do, that is called initialization. Whatever you do afterwards, that is called modification. Of course, static variable you can modify. Every time you are updating, every time you are modifying. Every time R is equal to N. But the problem is, I think there, if you observe, R is equal to N is there in the N greater than 5C. One time only will execute. Are you getting? This will execute only once, na? This will execute only once. Because R value, see, N value 5 greater than 3, one time. One time only will execute. You don't execute again and again. Right? If at all, every time condition satisfy, every time it will update. This is happened only first time, na? This is happened only first time. One time happened, afterwards not happened. That is the reason it is not updated. But remember, at anywhere updation required, static variable you can update. Static variable you cannot initialize. Initialization means this one. Every time you cannot initialize. Static variable memory, right? Static variable memory once only. Static variable initialization is once only. Right? Next one. If you delay, static static variable if you delay, you may get updated value. Please be careful. So 99% will come in the exam. So these are the important points. Static variable memory will create only once, right? And memory created compile time. This is also called static binding. Compile time, memory creation, static binding. Why memory is one time? Because of memory created compile time also one time, na? One time compilation, so one time memory. Static variable memory created once. Why? Memory created compile time. How many times you will compile a program? One time. Memory initialization also one. So why? Right, compile time itself you are creating, so that time only initialization, right, like that. So please be careful. I hope everyone is comfortable. Let's move to. So if you see the output, right, 5, 7, 9, 18. So what is the answer? 18. These all are false. Answer is D, right? Answer is D, which is 18. Okay, perfect. Just I given one example, nothing. Let's see this. Let's see this. Can you careful about this? One more problem. Can you careful about this problem also? What is the output of this program? What is the output of this program? Main program onwards start. I think initially ABC is 0. Initially ABC is 0. So please take care of this also. Please take care of this also, because it will come in the exam. That is the reason I kept here. Because it will come in the exam. That is the reason I kept here. Int ABC is equal to 0. Okay. Okay. These are the global variable. I think they will create in the static area only. Please be careful. A, B, only for namesake I am writing C. Right. I think because of you didn't kept anything. ABC 0, ABC 0. You didn't kept anything here. So C value 0. C value 0. And global variable by default 0 only. Because static area. Right? Global variable memory will create in the static area. By default, they will also be 0. By default, they will also be 0. Right? Local variables by default garbage. Now, anyhow, come inside. Come inside. It's not a big issue. It is not a big issue. Come inside. So start from main program. Initially A, B, C equal to 0. C 0, A, B not kept, but global variable memory will create in the static area. So by default, that is 0. Don't worry. By default, that is 0. So this is the current status. Now you can go to the main program. Go inside main. Inside main, if you go, static int A is equal to 1. Remember, is the local variable. Local variable. So this is the local. Understand. In the main one, local variable there. A1. But it is a static variable. Remember, it is a static variable. It is static area, it will store, but it is a local. E is also created, E is also static area, but these are global. Remember. Don't confuse. One local variable, which is static, it is also stored in the static area. There are 3 global variables. They are the global variables. They will also store in the static area. Both are storing in the static area. It's okay. Right? But some are global, some are local. Now see this one. Print, right? Something like print function. Can you go to print function? Can you go to print function? I am not teaching anything here. Just I am revising one time. I am not teaching anything here. Just I am revising. Nothing, no new teaching here. Just whatever you know, I am explaining one time. So can you see this one? Static int A is equal to 2. Here also, once again, one local variable, which is static keyword. Means static area memory will allocate. So this also over. Next one, int B is equal to 1. Remember, it is the stack area. It is the stack area. It is the stack area. Please be careful. It's a one local variable, but stack area you will allocate. Okay, that is also okay. Next one, A plus is equal to plus plus B. So remember, this is called shorthand operand. Shorthand operand. Right? So this will be done right hand side will be first 2. Plus plus B. B became 2. So A is equal to A plus 2. A is equal to A plus A is already 2. 2 plus 2, 4. A value became 4. Print, now see some print AB. A4, B2. A4, B2. So first output is 4, 2. First output is 4, 2. Afterwards, you will go back to main. Now listen. See this one. Whenever you say this is completed, careful. Whenever you say this is completed, only static person is available. Remaining people are gone. Whenever you say this function is completed, only static person is available. If you call this function again, this static variable, you can reuse it. Sir, local variable lifetime is within the function. Yes, if you create memory in the stack, but you are creating in the static area. You are creating memory in the static area, so it will be available. Even the function over, it is available because static variable lifetime is total program. Be careful. Now come back. A plus is equal to 1. Remember, A is a static variable here. So it became 2. Right? So print function again you called. See the answer. Print function you called again. Now see the answer. Static int A is equal to 2. No. Initialization is only one time. Already you done, so you cannot do again. Now B is equal to 1. One more local variable B created, which is 1. Because it's created in the stack is already gone. Now plus B, it became 2. A is equal to A plus A, already 4. 4 plus 2, 6. Afterwards print AB. Afterwards print AB. Afterwards print AB. What is the answer? I think it is going to be 6 will be printed, 2 will be printed. 6, 2. 6, 2. So now control will go back, then again B will go. But remember, A is still available. If needed, you can use afterwards. Next one, print AB. But in this function, if you see A2, in this function, if you see B, interesting answer. In this function, if you see B, what is B? In this function, if you see B, are you kept anywhere B in this function? In this function, B nowhere you kept. B is, I think, what is the answer? If no local, you will take global. B value 0. B value 0. What is A? A2. B 0. No local, you will take global. Global people by default 0. Global people by default 0. So this is the answer. 426220. I am not teaching anything new here. Nothing new. Just I am saying important points. Static variable is important. Static variable recursion is important. Please be careful. Local variables by default garbage, right? Global variables, they will store in the static area by default 0. Okay. Now same program, please understand. Same program, when you replace line 1 with auto int A. Remember, int A, auto int A, same effect. Line 1, if you replace with auto int A is equal to 1. Line 2, if you replace register int A is equal to 2. Line 1, line 2. Where is the line 1, line 2? See, line 1 means this. Line 2 means this. So line 1 is auto int A is equal to 1. Line 2 is register int A is equal to 1. Register int A is equal to 2. If you replace like that, output will be like this. Please be careful about auto. Right? Auto int A means this is equal to int A. Both are same. Next one, register int A is equal to 2 means this is also int A is equal to 2. Please be careful. Simply no static. Simply this program, right? The above program, no static is there. Auto int A is equal to 1 means int A is equal to 1. Register int A is equal to 2 means that int A is equal to 2. It means indirectly want to say above program, what is the output? If no static, here also no static, here also no static, what is the output? Check once, nothing is there. So remember, these all three are similar. This all three are similar. We said many times in the classroom also I said. So check yourself, answer become 424220. 424220. Last level printing global. That is the reason 0. Why 42? First time when you call the right print function 42. Second time also 42 because there is no static variable. Third time 20, right? One is the local variable A will be printed 2. One is global variable B will be printed 0. Okay, perfect. One more important topic is coming, pointers. This is a very important one. For GATE examination point of view. Most of the questions will come from, right? Remember, in the right C programming, GATE examination, C programming, mostly static variable and recursion, pointers also one more. So 90% of the questions of C programming will come from here. 90% of the questions. I'm not saying 90% it will come. I'm not saying 90% of the questions of C programming will come from pointers. And one more, this will surely there 100%. 100% in the GATE examination, right? Pointers will be there. You will never see a CSE paper without pointers. 100%, not 99 also. 100% pointers will be there in the GATE exam, right? So 90% questions of the C programming in the GATE exam, right? Definitely from the pointer. Remaining 10 may be static variable, maybe recursion, something like that. But anyhow, let's come to one by one. Let's come to one by one. Yes, perfect. Right. So let's come to right pointers. First one, int a is equal to 10. Next one, int star b is equal to ampersand a. Int a is equal to 10, int star b is equal to ampersand. So a is saying that I want integer data, okay. B is saying that I want address of integer, that is also okay. When you say print percentage u ampersand a address will be printed. Print percentage, right, print percentage u b, that is also same, a address only printed. Next one, print percentage d star b, the value at b, b is containing address, star b, the value at that address. So a value only printed. So it is a normal. A pointer can only point to a variable of the same type. Yeah, you know very well, just check one time. Right? But to store any type of pointer, we need 8 bytes. Let us assume that address to store 8 bytes. Let us assume. Right? Integer pointer contain address of an integer. So he said, right, you can read this properly, same meaning. If you declare pointer as an integer, it can only store the memory address of an integer variable. If you say int star a, so if you say int star a is expecting address of integer, you have to give address of integer only. When you say int star a, you are expecting address of a integer. So you have to give address of integer. That is the purpose of first point. This is second. And one more thing, you know very well, right? AI is equal to star a plus I. In the addition, a plus b is equal to b plus a. This is also correct, right? So if a star a plus I is a of I, why not this as I of a? So I of a also you can write. All four will give same answer. Everyone know this, right? Now, next one, 2D array, same thing you can replicate. 3D array, same thing you can replicate. Same thing you can replicate. Here you can write, right? Star a plus I, so you can write star I plus a also. Plus j, star. Right? You can replicate same way. There's no problem at all. Let's go to one problem. One character array. One character array, last character is null character. Because of you given in the form of a string, last character is null character. Int a is equal to strlen of s. Int a is equal to string length of. Int a is equal to string length of s. I think string length means string length only, 4 will come. Size means including null character, 5 will come. So 4, 5 will be printed. Okay, that is also okay. Everyone know this. Now let's go to next one. The ASCII value of the null element. Remember, the ASCII value of a null character is 0. The ASCII value of the null character is 0. Please be careful. That is the reason. If null fail, because it is if 0. When you are checking the conditional statement, if null fail, because null character ASCII value 0. The ASCII value of a null element, right, 0. Next one, printf percentage s. Right? So remember, when you are printing a string, while we use percentages, it start printing from the given starting address till null character. When you are printing a string, if you give base address, it will keep on printing everything from that base address until null character. You don't print null character. By seeing null character, you will stop. Right? Only for namesake, I given one example. Can you see this one? One array. Right? So if you see the addresses here, 0, 1, 2, 3, 4, 5. These are the indexes. Addresses 1000, 1002, 1004, 1006, 1008, 1010. Okay, fine. So A is okay. B. So I think if you want, I will write like this. If you want, I will write like this. A, because there may be a need. 1, 2, 3, 4, 5. Let me write 10 here, 20 here, 30 here, 40 here, 50 here, 60 here. So it's going to be 0, 1, 2, 3, 4, 5. It's going to be 1000. It's going to be 1002, 1004, 1006, 1008, 10. Okay, that's okay. Next one. Remember everyone. I am not teaching anything new. This is the revision class. It will be faster. I don't care whether you are getting or not, because it is a revision class. If I care also, what I can do now? I cannot do anything. Right? I cannot do anything. Entire year you are keep quiet. Entire year, if you don't do, you don't get now. Entire year, if you are working hard, so this is very easy, right? Everyone is address now, so 8 bytes. If anyone says, sir, I am not getting, I don't care, right? So the reason is this is the revision, right? Revision is revision, right? If you are already done nice work, you will easily get it. So now next is one, a plus 3, right? I think if you observe clearly here, everyone is here 2 bytes. Here everyone is here 8 bytes. Be careful. So a means first array, plus 3 means 3 to 6. So 1006. It's going to be 1006. A plus 5, 1010. Right? Next one, a 1000. Right? A plus 2, 1004. A plus 1, 1002. Right? Next one, a plus 4, 1008. It's just a revision, one time I want to say, that's it. What kind of problems you can expect. So remember everyone, arrays pointer, one more combination. Arrays static variable, one more combination. Arrays pointer static variable, one more combination. Or recursion. These 4 will come. See this one. Arrays static variable, recursion, pointer. GATE paper of CSE contain these only. GATE paper of CSE contain these only. Combination. Either individually will come or combinedly will come. Individually, combinedly. These 4 only there in the paper. Array, static variable, recursion, pointer. Indirectly, directly, this combination only there in the exam. Right? Be careful. Please practice few problems. You can easily do it. In star C is equal to B. So C is a one variable which contain B. Array means base address 2000. C having its own address. So C is pointing to here. Okay, that is also okay. Now C++. C pointing to 8 byte person. When I say plus plus, it will become, right? It is a 3000. 3000 plus plus also 3000. Because it is a post incrementation. Afterwards, it will change. C value became 2008. Afterwards, it will change. Not here, here. 2008. Right? Fine. Sorry for this one. C is 2000. No? C 2000. Inside C. Variable means inside. Inside 2000. 2000 plus plus also 2000. Okay, perfect. Till now, okay. After completion, it became 2008. Now observe. What is C? What is C? 2008. What is C? 2008. Minus B, 2000. So both are pointing to 8 bytes person, right? So 8 they divide by 8. Because, right, C also pointing same, B also pointing same, where every person is 8 byte. You have to divide by 8, which will become so on. So first one. Subtraction will give number of elements. If you don't divide, that is also correct, but that will give memory size. But subtraction will give number of elements. You have to divide by 8. Why divide by 8? They both are pointing to some array where every person is 8 bytes. Now remember, this will also give number of elements. Let's see how. C is 2008. Right? Remember minus and star. Star having highest priority. Star 2008. Star 2008. 1010. Minus A. A is 1000. So remember, these two are pointing to here. See, 1010 also here. 1000 also here. So this will goes to 1010 minus 1000, which is going to be 10. But here every person is 2 bytes. By 2 you do. So which will goes to 5. Why by 2? One element size is 2 bytes. Why are you dividing? It should give number of elements. Okay, I done this. Okay, I done this. Now let's go to last one. C 2008. Star 2008, 1010. Star 1010, the value inside 1010, 60. So 60 will be there. So that is the one, I think everyone know this. One array problem I want to give, I give it. Right? So next one, 1D array. 1D array plus 3 means skipping 3 elements. 2D array plus 3 means, right? Skip 3 rows. Right? Next one, star means row is selected. You don't give value, row selected. 3 rows skip and select row, because star happened, and select row. The meaning in the 2D array is star a plus 3 means it is the address only, because 2D array 2 stars required to get the data. 2D array to get the data 2 stars required, but 1 star address only will come. But what is the meaning? Plus 3 rows skip. Star, after 3 rows skip, you may be there in the 4th row. If you start from 0, 3 rows skip, 0, 1, 2 over. You are there at the 3rd row. Star, 3rd row we selected. 3rd row selected. Now, whenever you say 3rd row selected, in the 2D array, 1 star over means it became 1D array. From now onwards, in the 1D array, you are walking. So, after 1 star is over, if I do plus 2, 2 element will skip, because in the 2D array, 1 star over means now you became a 1D array. 1D array plus 2 elements skip. See, 3 rows skipping. Then afterwards, you done the star. Then I think 1 level is gone. Plus 2 means 2 elements skipping. You know this very well. I'm not saying anything new. Just I'm reading one time. Just I'm reading one time. Please be careful. Right? Now come here. Now come here now. So one more, because most expectedly array and pointer combination will be there, or array and recursion combination is there. So let me write the once again now. So most probably in the examination, you will see arrays, you will see recursion somehow, array and recursion combination, you see the static variable, or you see the pointer. Anything else? Anything else? Let's see. Anything else? Let's see. Static, recursion. Yeah, same thing. So combination, this only there. Arrays will be there, recursion will be there, static variable will be there, pointer will be there, or their combination. They will just check the basics. Let's see the basics. Let's see the basics one time. So this problem, it is also one of the nice problem. You can see one time. He's just checking. Are you comfortable with the 2D array or not? Are you comfortable with the 2D array or not? He's checking. Let's see. 4 rows, 5 columns. 4 rows, 5 columns. First row. Second row. Third row. I am not teaching anything new. Again and again, I'm saying I'm not teaching anything new. Please try to understand. Just I'm reading one time. I'm just saying important points and I'm reading one time. Please go through it one time. So whatever you studied, okay, you studied already something. You already studied the total C programming many times. You can see this one time also. It may give some idea. Totally 5. 0, 1, 2, 3. 0, 1, 2, 3, 4. Array name is A. Addresses, if you see, it's a 1000. By default, row major order. Go row by row address. 1002, 1004, 1006, 1008. Right? 1010, 1012, 1014, 1016, 1018. 20, 22, 24, 26, 28. 30, 32, 34, 36, 38. Right? Like this. Now let's move to inside. Values I am giving 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Remember, red color things are values. Right? So other color is going to be addresses. Be careful. Be careful. Right? So our address is starting from, assume base address 1000. So in the problem, is nowhere mention a base address. You take whatever you want. If they don't mention anything, you take whatever you want. They didn't mention, you take whatever you want. Sir, how can I take? Because anyhow, it is not matter. It doesn't matter in the answer. Take any base address. Sir, is not mentioned one element size also. Take whatever you want. Integer, I am taking 2 bytes. It doesn't matter. That the reason is not given. Right? So remember, values are red color. Be careful. Red color or purple color, whatever it is, red color. So I think everything is ready. Now start. Now start. I think everything fine. So go inside. See this one. Start from operand. Start from operand. So A plus base address 1000 plus. Okay. A plus base address 1000. Inner bracket you should do first. It's very tricky. Be careful. Inner bracket you should do first. Okay. A 1000 plus. Now go here. What is A here? See this one. What is A here? It is also 1000. Okay. For this A purpose, plus also fighting, star also fighting. So everyone knows, see the table also. See the priority table also, star having highest priority. Star having highest priority. So just wait one time. Star having highest priority. Yeah, you can see the table. You can see the table. I want to show the table, but anyhow it will take some time, right? So you can see the table. A is 1000. So star 1000. The value inside, right? A is 1000, na? Star 1000. Star 1000. The value inside 1000. Inside 1000. But remember, it is a 2D array. You don't get value. You don't get value. Remember, star 1000 means 0th row selected. Wherever you are, that row selected. Try to understand. Because you said star. In the 2D array, star indication that, right, row selected. But without adding anything, how row selected means wherever you are, that row selected. In 0th row selected. I am there initially 0th row, directly star. Oh, 0th row selected. Next one, once again star. Remember, 0th column also selected. 0th row selected, 0th column also selected. Try to understand. Okay, fine. Until now, fine. 0th row selected, 0th column also selected. That means value will come. This is 1. This is 1. After this 1, next one is plus 2. So 1 plus 2, which is going to be 3 overall. Which is going to be plus, right? Which is going to be plus 2. Overall is 3. Overall is 3. Please check. So it is 3. But remember, inner bracket only we are doing. A plus 3. Everyone try to understand. As of now, A plus 3. 3 rows will skip because to this you are adding. Here there is no star. 3 rows skip. 3 rows skip. So you are at here, which is nothing but as of now. As of now, this one will give. As of now, this one will give 1030. Because 3 rows skipping. Every row 5 people. Right? 3 rows means 15 people. 15 into 2, 30 bytes. 1030. Till now, this is the status. Now, afterwards, you came outside the bracket. Now you done star 1030. Same only. There is no change. But row selected. This row selected. This row selected. In that row, plus 3. 3 elements skip. So I am at here. So it became 1036. Afterwards, lastly star. The value 1036. So 36. 36. Sorry for this one. The value at 1036, which is 19. 19. Remember, red color things are values. It's a very, very interesting one. It's a very, very interesting one. Please be careful. It's a very, very, just verified basics. Are you strong or not? Just verified. Are you okay with the basics or not? I am not teaching anything new here. I am not teaching anything new. Whatever you know, just I am reading one time. You are not getting, I am also not getting, because this is not the time for getting and all. This is only for revision time. This is the revision time. This is the revision time. I hope everyone is perfect. This is the revision time. I hope everyone perfect. Right? Something not clear, please ask in the comment section. I will come. I will definitely do that. So answer for this 19. Please be careful. These kind of questions you can expect. You can expect these kind of questions. Okay. I'm thinking you are absolutely fine. Little doubt also there. Please check. Many games he played. This expression contains many games. It look like very small, but it is played like anything. They played very good game. Now come to the next one. One more problem. One more problem I give. One more problem I given. Something it's going to be very dangerous problem. This problem you can handle means you can handle anything. This problem you can handle means you can handle anything. Let's go to global variable first. Right? You will also check here many combinations. Please be careful. Let's go to global. 2 arrays are there. 3 arrays. Lastly, pointer array. Let's see. Let me write pointer array only. Only pointer array you take, which contain 3 slots. 0, 1, 2. So let's give addresses. Because of addresses, everyone 8 bytes. Right? So assume that this is starting from 1000. This is starting from 2000. This is starting from 3000. Oh, 1000 already there. Let me give something else. This may be 4000. This is a 4008, 4016. So here 1000 there, here 2000 there, here 3000 there. So, but remember, X is expecting address of integers, but you give an array. Yeah, giving array address means giving first person address. So first person, if I go there, integer only there, right? If I go to the first person here also integer only there. Inside 2000 integer there. If I go to first person here, right? Here also integer is there. Inside 3000 integer only there. So everywhere I am expecting address of integer, but you are given address of a base address of a array. Base address of a array means first person address. So everything perfect till now. Nothing special. Simply three arrays are they stored in the one pointer array. One pointer array you stored. Let's go to main program. In the main program, you done print x. Remember, it is not print fx. Simply print x function call. So x means what? Base address 4000 going. X means base address 4000 going. Yes. Remember, array cannot come. Base address only can come. Here A is not array. Here A is not array. Right? Please understand. Here A is not array. Right? Base address is K. Base address is K. Please try to understand. A contain now 4000. Base address K. Array cannot come. Base address will come. Right? So from here, right? X means 4000. 4000 K. Base address. So it became like this. Okay. Until now it's okay. Until now it's okay, but understand it is a base address of listen, it is a base address of inside 4000. If you see one more pointer there, remember it's a pointer array. You want to say that, see, it is a array which internally contain a pointer. You want to say that, you have to convey that it is the address of, right? So see, this one very clear. It is the address of one array. It's the address of one array where inside addresses are there. He said very clearly, but remember, inside the print function, a is a one variable. You want to say that whatever is k, right? It's address only. It's a variable only. But if you see the clear story, right? This address, if you observe clearly, it's address of one array where inside addresses are there. That is okay, but remember, everyone try to understand. A is a pointer variable. Try to understand. Now see, don't be emotional. What is the meaning of this? Let's see. A02, right? You may be having some emotion. Computer don't have. Just you will do calculation like this. You will do like this. Whenever you return the array format, you will just convert into formula. This is the formula. Right? Be careful. A is 4000. 4000 plus 0 is 4000. Star 4000. Star 4000. The value inside 4000. I think it is 1000. The value inside 4000 is 1000. 1000 plus 2. So remember 1000 plus 2. 1000 plus 2. See, in this array, every element is 2 byte. Plus 2 means 2 elements skip. I will be here. So 1000, 1000, 1004. It became 1004. Star 1004. The value inside 1004, 8. It will be 8. So first one should be 8 printed. Be careful, be careful. I am not saying anything new here. I am not saying anything new. Whatever you know, I am saying, but the only thing is I am going little faster. Most expected these kind of questions. Most expected these kind of questions. Please try to understand. This is completed. Next one, print percentage D star A of 2. Understand this? What is star A of 2? Let's check. Don't be emotional. Don't be emotional. What is the meaning? Let's check. Star A of 2. Try to remember star and bracket. Bracket having highest priority. This became A plus 2 star. Outside one more star. Star having, bracket having highest priority. You can see the priority list. Star operator, bracket having highest priority. Now listen, A is 4000 plus 2. Plus 2, remember, 2 elements skipping. 4000, na? So 4000 is where? Here. 4000 is here. Right? Plus 2 means 2 people skip. 4060. It became, right? Plus 2, it became 4060. star, right? 1 star. The value inside 4016, how much there? The value inside 4000, how much there? 3000. The value inside 3000, what is there? Because of here 2 stars. The value inside 3000, what is there? Minus 12. It became minus 12. I am not saying anything here. Just I am reading one time. I am doing little faster. So first output is 8. Next output is minus 12. Now understand this also. Careful everyone. Plus a of 0. Plus a of 0. Which will goes to bracket having highest priority. Plus outside. So a is 4000. 4000 plus 0 is 4000. Star 4000 is, I think, 1000. Plus. Right? So remember, it is a plus. When you say plus, it became 1000 plus is 1002. Afterward, there is a star also outside. So star, right? The value inside 1002, right? The value 7. The value inside 1002, 7. Please check properly. But remember everyone, right? A of 0. So this one you updated to 1002. Updation is done. So it became 1002 star 1002, which is going to be 7. 7 printed, okay. But you done the updation, it may affect afterwards. So like that, you have to do this. So until now, if you observe clearly, first output, check properly 8. Second output, minus 12. Third output, maybe 7. Right? Like that. So these are 8, minus 12, 7. Until now, perfect. You verify? So answer is A. You verify, answer is A. I think 2 more printfs are there. Verify. It look like option A. Please check. So I will give the meaning and we will move forward. What is the plus A of 0? So understand everyone. So 2 brackets are there. First bracket should be done. Do plus A. So A is already 4000. Plus A. It became 4008. So let me write now. Plus A. Star outside already there of 0. This is a very tricky thing. Very tricky thing is playing. This will goes to plus A. A is 4000. Plus A is 4008. It became 4008 of 0. Star outside there. It became star 4008. Outside again star there. Because you have to do this first. So finally this is star 4008. 4008 star 2000. 2000 inside 23. So 23 will be printed. Interpretation is always important. What is the computer point of view? Meaning. Same thing here also. What is the meaning of this? Let's check. A minus, same story. A minus 1 star plus minus 1 star. That's it. First of all, what is A? Already you are incremented. It became 4008. 4008 minus 1, it became 4000. Star 4000, the value inside 4000, 1002. Previously you done this. Minus 1, it became 1000. Star, right? It will became, right? The value inside that, I think 8. First value. How much first value? Star 1006. 6, na? Check one time. Verify properly last value. Oh, it is a plus 1. Sorry for this. Plus 1. Plus 1 means, right? Let me write here. Plus 1. So it became 1004. The value 1004, 8. It will become 8. Right? That is the reason. So 8 came. So I am not doing anything just to do properly. It is one of the complicated problem. This is very important problem. This problem you are okay means you are okay with anything. That is the reason I selected this problem. This problem you can do means you can do anything. This problem you can do means you can do anything. It is a very important one. Please have a look one time. This is a very important one. Please have a look one time. Sir, someone is saying, sir, what precedence shall we follow here? Please revise once, sir. So there's nothing, right? See the table. See the table whatever say, do that. Right? In the classes, every class I used to show. Right? If I say now, confusion only will come. I cannot teach anything now. If I say now, confusion only will come. Sir, any shortcut for this problem? Instead of assigning memory address to each element, otherwise you are gone. How can you do any shortcut here? If you do that, you are gone. Without giving address, if you do, it's gone. It's impossible. It is going to be create a lot of problem. This is one of the tough problem of total C programming. That is the reason I selected the tough problem. This is one of the tough problem I selected. This problem you can do means you can do anything. This is the table. Operator precedence table. Please go through it first. See this one. Bracket is there in the first place. See this. Bracket having highest priority. And one more. What about star? Right? You can see this. See, star is there in the second place. Comparing bracket and star. Bracket having highest priority. This star is a multiplication. This star is pointer. This star is multiplication. Right? So please see the table. One time. Right? If you go to the exam prep tool, there is a GATE CSE. Click on that. You will see important tables. Important tables for GATE CSE. So you can go there and you can see the tables one time. Right? Fine. So here I think one more table, closure property table also there. Please take care. This table also important. Please take care that table also. Right? Undecidability table also there. Please take care. This table also please take care. Undecidability table. Right? These three tables please careful. Guarantee some marks will come. These three tables please be careful. Guarantee some marks will come. Let's come back. This is a very, very difficult problem. If you can handle this one means you can handle anything. Right? Let's move to next. Answer for this one is option A. Let's go to next. So pointers are very, very important one. Let's go to structures and union. Structure is not an array. It combines different kinds of data types. Structure is not an array. It combines different kinds of data types. Okay. Inside struct, we cannot assign. See, here you cannot do this. Int A is equal to 5. Int float B is equal to 6. You cannot do this because you are creating one data type. So please be careful. It is not an array. It combines different kinds of data types into one new data type. Inside structure, you cannot assign because you are creating one data type. Next one, after completion of this, right? So I created one struct names called example, one integer, one float, one char item. Go inside. So integer, float, char. I think it is a 7 bytes. So for right, one variable D created, which internally contains 7 means 3 parts. 10 here, one integer, one float, one char. So it's maybe A, B, C like this. You know very well. Next one, after completion of this one pointer variable, you are taken P. This is address is 1000 here. This address is 2000 here. So inside P, you stored D address. It is 1000. So you will point here. So whenever pointer itself is address, they will try to understand. Pointer means address. Without address, what we can do? We cannot do anything. Pointer means address. Na? Without address, you cannot do anything here. You have to assign address whether you like or not. You have to assign the address. Okay, fine. Until now, fine. Now, next one. P is 1000. Star 1000 means inside. Dot B means 20.5. So this is the actual. This is the shortcut. Next one. P pointing to 7 bytes person. This is the 7 bytes. P pointing to 7 bytes. If I say P plus 7, P plus 1, right? P plus 1 here. P plus 1, it will goes to 1007. P pointing to see this entire thing is 7 bytes. When I say plus 1, right, I think it will increase 7 bytes, 1007. If we do P plus 1, then we will get 1000 plus 1, which is 1007. Next one, a structure includes one integer, which is 2 bytes, one float, 4 bytes, one char, 1 byte. So 2 plus 4 plus 1, which is going to be 7 bytes. That is the reason. Right? Now come here. Now come here now. What is the difference between structure and union? Here, if you see 4 floats, now 16. This is 2. This is 1. Total, if you observe, can you check here? 4, 4, 16. Let me check here. 4, 4, 16. Right? One integer, but it's a character pointer. Remember, pointer means 8 bytes. So, right, it's going to be 24 plus 2, 26. This is for this 8 bytes. Totally 26. But if you observe here, it is 2, it is 16, it is 8. But when you say union means bigger one. So 16. Union means bigger one, 16. So this is for structures. This is for union. So maximum memory used by single unit. This is for union. That is the difference. When you say structure, total you take. When you say union, bigger one you take. When we know that at a time only one will be used. When you have clarity, I will use only one person because overwriting will be there. One person memory, other people have to share. But in the case of structure, every person having their own memory. No sharing here. But in the case of union, sharing is there. Right? Bigger person memory will be given to all the people. One time only memory given, bigger memory. So everyone can use that. Sharing is going on. Right? Fine. Yeah, let's complete this. Let's complete this. Right? Let's complete this one. Thank you. Thank you so much. So when we know that at a time only one will be used, then you have to go for union. Okay, perfect. Now let's move to right some problem. This is also going to be very tough problem. Be careful. This is going to be very, very important. See, this is the next example. This is the next example. I kept so many stars also. It is a very, very important. Please see one time. Please see one time. So I 2 bytes. Pointer 8 bytes. Totally 10 bytes. Right? Next one. It is 10 bytes. 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 Like that. 10, 10. Right? Approximately, I think 5 people, 50 bytes of memory. Everywhere you will see IC like that. Right? Fine. Now see this one. First one is 5. Next one, let me write here. Here 2000 I am writing. So it is a year. Don't confuse. Here I am writing 4. This is 3000 I am writing. Storing string means storing base address. Here I am writing 6 and 4000. Careful. Right? If you don't write properly, there may be chance of mistakes will happen. It is a 5000. It's going to be 7 and brother maybe, which is going to be, I think, 6000. If you write properly, more clarity will come. If you write properly, more clarity will come. Now this is the current status. 0 here, 1 here, 2 here, 3 here, 4 here. Now observe. Sir, data structure and notes PDF. Kaha se? I already given link also, right? Rakesh, see the link. Rakesh, link also provided. Can you go there and can you check? Right now understand. Now understand everyone. Everyone try to understand. Everyone try to understand. Everything is ready. So P contain 1000. ST is 1000. P also contain 1000. Now understand P plus 1. Because of everyone is 10 bytes now. Plus 1. 10 bytes will increase. This is going to be 1010. So P is pointing here. Next one, P arrow C. Now understand, this will kill the people. This will kill the people. Go priorities. Go priorities. P arrow C plus plus. Remember, arrow having highest priority. P 1010, right? P arrow C means 1010 inside C. So it is a 3000. So plus plus. Remember 3000. 3000 wherever 3000 pointing plus plus. You will point to next character. So it became 3001. Until now, it is a 3001. Understand? So So be careful. So 3001. So it is updated also. This line is over. Now come here. Now come to this line. Come to this line, which may create some trouble. Please see. P plus plus arrow C. P is, as of now, P is 1010. P plus plus. Remember, it is a post incrementation. 1010 only. 1010 arrow C. Now only we done 3001. Right? 3001 onwards, whatever there, it will print. 3001 onwards, what is there? 3001 onwards, what is there? Right? I think iter will be printed. 3001 onwards, iter will be there. That will be printed. Okay, that is okay. That is okay. Now let's go to second. Now see the careful, because of this only we came here. See this. Small mistake also, some other thing will come. P arrow C. And one more important thing is, in the OPER, one incrementation already you done, post incrementation. It will affect now. It will become 1020. That time it is not affected. It will affect now. It became 1020. Now observe. It's a 1020 arrow C. 1020 arrow C. 1020 arrow C is going to be this. I think 4000. 4000. 1020 arrow C, it's a 4000 plus. It became 4001. Check if I am doing anything wrong. First increment, then star. P arrow C is going to be 1020 arrow C is 4000. Plus means 4001. Star, the value inside 4001. The value inside 4001. The value inside 4001. It is a 4000. 4001 is this, U. The value inside 4001 is U. U will be printed. So second one should be U. Sorry for this. It is a not N, it is a U. That is the reason I cross verified one more time. Now let's go to third one. Let's go to third one. Careful. Right? P of 0 dot I. P of 0 dot I. So this means, right, it is a shortcut actually, star P plus 0 dot I. So what is P? I think if you observe clearly, above, if you observe, it became 4001. It became 4001. So I think P is 1020 only. So 1020, right? 1020, it is 1020 star. You went inside 1020. Okay. Star means you went inside 1020 dot I. So 6 will be printed. Dot I, 6 will be printed. This is also okay. 6 will be printed. Lastly, P arrow C. I am not saying anything new here. I am not saying anything new here. P arrow C directly. So at this place, nothing is incremented. P arrow C. What is the answer? P is 1020. Arrow C. 4001 onwards, right? 4001 onwards, whatever is there, it will be printed. 4000 onwards, what is there? UNGLE. Do once again. It is a very tough problem. It may be trouble you. Right? This problem you are okay means you are okay with everything. This problem okay means okay with everything. Let's go to next. Yeah, I think Rakesh, it is there in the comment section. It is there in the comment section. Please take care. It is there in the comment section. Please take care. Now let's come to typecasting. Let's come to typecasting once, right? So integer is 2 bytes, float is 4 bytes, carry is 1 byte. Right? See this one. I think in 1 byte you can store 2 bytes, no problem. Sorry, in 2 bytes you are storing 1 byte, no issue. But anyhow, types are not matching. You have to do typecasting because of no issue, because in more memory you can store less data. Actually no issue, but rules are saying there is an issue, so it will give warning. What it will do is implicitly conversion will be done. Implicitly conversion will be done, right? It will give warning so that next time onwards you will take care. So smaller data, bigger memory, there is no issue because implicit type conversion. But C is equal to B. C is 1 byte, B is 4 bytes, right? 4 bytes you are storing 1 byte. There is a problem. You will get error. This is called, you have to do typecasting by yourself. If is like this, because if it is a serious issue, it will give error saying that you write by yourself. You have to do explicit typecasting. How to do? If you do, right? So you lose the data, but because of you are explicitly writing, I want to lose, there is no issue. If you write like this, there is an issue, it is an error. Because you are losing data. Even though you are losing data here, but you are explicitly written, I am ready to lose. Out of 4 bytes, I want to take only 1 byte. Then there is no issue. So it will simply, don't give any error, it will allow you. So what I mean to say is, if you want to convert, you can do typecasting. Right? Different types you are storing. Different types you are storing. You have to do typecast. Either system should do or you should do. If at all no issue, system will do directly by giving warning. If issue is there, system will give error. So you can do, that is called explicit typecasting. But remember, that is the data typecasting, which is really not required. So pointer typecasting is important. Pointer typecasting is important. Pointer typecasting is important. Right? See this one. One example. It is exactly directly from my classroom notes. So I taken the screenshot. Classroom notes, I taken the screenshot. Understand once. Everyone listen. Int I is equal to 300. Convert into binary format. This is the binary format for 300. I is equal to 300 is the binary format. Right? So I think if you observe here, 256 plus 256 plus remaining 34 whatever, 44 whatever there. This is the 256. This is the 44. Total become 300. But inside memory, how it will store? So remember, inside memory, how it will store. Suppose if you take 2 bytes, because the integer is 2 bytes, this is the 300, this is the 300 in the binary format. I want to store inside memory 2 bytes. How it will store? In lower byte, who will store? Lower byte, right? This one, lower address, who will store? Lower address contain lower byte. In lower address, who will store? Lower address contain lower byte. Right? So higher address contain higher byte. This is called little endian. In lower byte, who will store? I'm repeating once again. In lower address, who will store? Lower byte will store. This is called little endian format. In lower address, who will store? Lower byte will store. That is called little endian format. In the little endian format, this is the way how it will store. Big endian means what? In the lower address, we will store higher byte. That is called big endian. So this is the little endian. System follows little endian. If you want, you can check. How to check? You can see here. So this is the way how inside computer little endian it will store. Okay, next one. Star PTR is equal to ampersand is. Remember, I address. This is a variable I. I address is 1000. That 1000 address you convert into character address. This is the also 1000, but remember it is a character address. This 1000 is a character address which will store in PTR. Now PTR contain 1000, which is the character address. Remember. Now if you do character address now plus, it will increment by 1 byte. Someone is saying that, alright, Gaurav is saying that droppers batch. Gaurav, you have to do more practice. Yeah, you can WhatsApp us. We are going to help you. You can WhatsApp us. We are going to help you. This is the WhatsApp number. You can WhatsApp us. We are going to help you. Now remember, integer pointer, if I say +1, integer 2 byte, 2 bytes will increase. Character pointer, if you say +1, 1 byte will increase. Remember, PTR is a character pointer. Now see, printf PTR. So 1000 will be printed. That's okay. See, star PTR. PTR is 1000. Star 1000. Inside 1000, what is it? This is 44 will be printed. Because it will access 1 byte. What is the PTR +1? 1001. So remember, it is not incrementing. +1 it is doing, but it is not doing plus. PTR is 1000, +1 means 1001 because it is a character pointer. Star, the value inside 1001. So 1, it will print 1. After typecasting, this is the effect. See, with the help of PTR, PTR is going slowly 1 byte because it's a character pointer. Now see, PTR is 1000 plus. It is 1001. Star 1001 means this area. You are replacing 1 is there, you are replacing by 2. You are replacing 2. Now, if you say PTR, star PTR, 2 will be printed. Afterwards, I is a normal. I don't know this. I don't know PTR is doing like this. When you go inside I, it is the lower byte, it is the higher byte. I think this value is, I think, right, I think second bit, it is the higher byte, no? It is the 2 power, right, 2 power 8 to 2 power 9, 512. 512 plus 44, which is going to be 556. 556 will be, it is an excellent problem. It is an excellent problem for typecasting. It is an excellent problem for typecasting. Please take care. Right? So it is an excellent problem for typecasting. Little endian. Little endian. What is the meaning of little endian? Who will store in the lower address? Lower address will store lower byte. Right? So please be careful. Little endian, big endian format. Right? You should be take care about little endian, big endian format. What is the big endian? See this one. What is the big endian? Everyone observe. Everyone observe. What is the meaning of big endian? In lower address, who will store? See, lower address, higher byte will store. Lower address, who will store? Higher byte. So this is called big endian. Whatever we discussed above, that is the right little endian. Right, now next one. Similar way, one more problem I done. One, right, one array I took. One integer pointer variable I took. So I done the typecasting, right? A is the integer address, typecast to float address, which is stored in the C. C is a float address. D is a char address. A is a void address. Please remember, A don't have any type. Remember, B is a integer address. C is a float address. D is a char address. Right? Void is a, you don't have anything. Right? So when you say star, when you say star, right? Because of it don't have type, you don't know how many bytes it has to access. But when you say B is a integer type, star B, 2 bytes data you will access. 2 bytes. So from the starting place onward, 2 bytes it will access. Whatever it is, 300 is there. It will. So yeah, now see this one. It will say star C. C is what? Float type. Right? Star C means, right, from starting onwards, 4 bytes it will access. 4 bytes. So 4 bytes means, I think, this total, which will goes to very big number. Right? Next one, star D. D is a char type. When you say star D, I think, what is the answer? From starting onwards, 1 byte will access, which is 44. Next one, if you do star E, it will give error message. It will give error message. Right? Now next one, plus 1. Integer pointer plus 1, 2 bytes will increase. Character, right? Float pointer plus 1, 4 bytes will increase. Character pointer plus 1, 1 byte will increase. Next one, right? Void pointer plus 1, error message will come. So careful. Right? So next one. So everyone understand here? E is a void pointer. E is a void pointer. Void pointer, if you say plus also problem, star also problem. First to do typecast to integer pointer, then access, no problem. E is a void pointer. First to do float type, then do star, then you will get the same story. So I'm not teaching anything new here. Whatever you know, so I'm just whatever you know, so whatever we discussed, it is a classroom problem. It is a classroom problem. One time I'm revising. It is a classroom problem. One time I'm revising. So remember float pointer plus 1, 4 bytes will increase. Next one, float pointer star I done. Right? 4 bytes data it will take. That's what you want to say. Float pointer, if you say plus 1, 4 bytes will increase. Float pointer star, if you say 4 bytes data, it will access. Similarly, char. Similarly, remaining things. Right? Now, see, can you see this example? Can you see this example? Can you see this example? This will give some more clarity. This will give some more clarity. Can you see everyone here? Everyone can you see here? So 4 characters, I think 3 bytes. Okay, that is okay. See the main. Everyone observe, everyone is a 1 character. So struct our node P is equal to, so P contain all these people. P contain 3 people. X here, Y here, Z here. This is a 1 character 1, 1 character 0, 1 character A plus 2. Okay, that is okay. This line is over. Next one pointer variable Q you taken, which internally contain its address maybe. its address is 2000. I will point here. I understood. Till now, no issue. Till now, no issue. Try to understand here. So what is Q? Listen, Q contain 1000. Q contain 1000. Brackets are highest priority, right? Character pointer, right? Actually, Q contain, see this one. Actually, Q contain not character address. Q contains structure address. Q contains structure address, but you want to access as a character. Typecasted to character. Same 1000 only, but a character. When you say star, remember star plus fighting, star is winner. Star 1000, it will go inside. It will go inside, right? Inside 1000, it will go 1 byte. 1 byte contain 1. 1 byte contain 1. Remember, 1 is a character. Right? So I think until now, if you observe clearly, let's see what is happening. Let's see what is happening. So Q is a 1000. You done the right. Q is a 1000, right? So but when you observe here, inside it is a structure, right? Our node type variable. It's our node type variable, which is of 3 bytes. Because of 3 character, 3 bytes. 3 bytes one, you typecast it to character. It is also 1000, but it is now going slowly. One by one it will go. But be careful about the brackets. If you are not careful, serious issue will come. See, this is inner bracket is done. Until here done. Now afterwards there is this bracket. Lastly star will come. See, star is last. Star is last. So plus 1. It became 1001 because it is a character pointer. Lastly star, the value inside 1001. So O will be printed first. So typecasting effect, I want to say. Again, it is 1000. Right? If anyone is not clear, can you see here? It is 1000. Typecasting to character. It is also 1000. Afterwards, because it's a character pointer plus 2. 2 bytes will increase. 1002. Afterwards, star. The value inside 1002. Right? The value inside 1002. What is the 1002? A plus 2. A plus 2. A is a character. A is a character. Character plus 2. What is the answer? For any character, if you do plus 2, right, ASCII value will increase. A is, I think, 97. 97 plus 2. 99. So, right, A 97, B 98, C 99. 99, C will be printed. Nothing there. If it is a capital letter, na 65. Capital A 65, small a 97. Right, fine. You know very well typecasting about character, right? You typecast it to character pointer. Slowly you are going by one by one. So I think that is also fine. Now remember everyone, recursion. Recursion is very, very important, right? Tail recursion means recursion at the end. Advantage with the tail recursion is writing equivalent non-recursive program so easy, right? Before that, whatever there, keep in the loop, nothing there. Tail recursions are very simple story. Then much work, right? While going back, much work is not there. But non-tail is very serious. You can expect non-tail questions in the examination. Non-tail means what? Recursion in the middle, not at the end. Recursion in the middle. See, recursion in the middle. Recursion in the middle. Recursion at the end, that is called tail, which is very easy. Recursion in the middle, if more than one recursion, serious issue. That is called non-tail. Non-tail means recursion in the middle, not at the end. If more recursions are there, it is more serious. Remember, more than one recursive call, you have to go in the form of a tree. So for the above problem, see, more than one recursive call, tree format. And one more, 4 statements are there, execute properly. 4 statements are there, execute properly. There are 4 statements, execute properly. Every time, every n value, 4 statements. Suppose n is initially given 5, right? 5 minus 2. 5 minus 2, so 3. It's not here, simply printing. Next one, a of 4. Next, printf n minus 1. N value is 5. 5 minus 1, 4, right? Sorry, 5 minus 1 is 4. Next one, lastly, right? Print n. So 5 will be printed. Same thing, repeat. Same thing, repeat. More than one function call. You have to go in the form of a tree. One function call. You can go in the form of a stack like this. one function call, you can go like this. It is easy. This is also tree only, but one array tree. If at all more than one function call, go in the form of a tree. After tree construction is over, see how the printing. I think you started here. Let me use another color. You started here, right? You started here. First this one, this is printed, okay? But to complete this, you are going further. Remember, without completing second one, I cannot go to third one. To complete this, you are going further. So this will be printed. This is called pre-order, right? So function calling is pre-order. Function execution, this is the execution thing we are asking, post-order, right? So function calling is a pre-order, function execution is a post-order. But see how it is happening. So it will start here, right? First it will print. This is the meaning of post-order, execution, right? We are talking about execution, post-order. This is the post-order. After drawing the tree, please follow post-order. What is the post-order? Left, right, over, then only root. Can I print root? No, left, right only. So left first, right? Next left, but right? Can I print root? No, after left only. This is called post-order. So 3 printed, next 2 printed, then I came here. Next 1 printed, right? Then I came here. Next 0 printed. Now next one, a of 1, I think termination. A of 1 termination, you can see there. You can see n less than or equal to 1, return. No printing. No printing. Be careful. No printing. You may be confused. No printing. After 0, this is gone. Because here simply return. Then next one, 1. Right? Next one, it is simply return. Next one, 2. This is over, mean this is over. Next 2. Right? This is over. Next 3. Right? This is over. Next 3. This is a of 2. A of 2. Where is the a of 2? I think this is a of 2. Please see. This is a of 2. You no need to do again and again. You no need to do again and again. Let me write here. A of 2 wherever previously you done. This is a of 2. You can reuse it. So what is the answer? I think in this a of 2, 0, 2 there. A of 2, 0, 2. It is 0, 2. 0, 2 or 0, 1? Sorry, 0, 1, 2. 0, 1, 2. 0, 1, 2 print. Okay, this is also done. Next one, 4. Then this is completed. Then 4. Then a of 3. So please see the a of 3. Previously what you done. This is the a of 3. 1, 0, 1, 2, 2, 3. 1, 0, 1, 2, 2, 3. So this is also done. Next 5. 2, 2, 3. Next one is 5. Alright, then completed. So remember, more than one function call. Draw in the form of a tree. Okay, that is the first thing. Afterwards, apply post order. Post order means after children's, then only parent. Children's I want to do, but left child over, but he is not over. So again, do same story, right? So that is, this is most expected question. Most expected question is non-tail. What is the non-tail? What is the non-tail, right? Recursive call in between. Recursive call in between. That is called non-tail. Recursive program expected. Recursive program is expected, but in the middle, more than one also expected. More than one also expected. More than one is there, that is also non-tail, right? Only one in the middle is there. Only one in the middle of the recursive program, it is there. That is also non-tail. More than one is there, it is also non-tail. So more than one function call, go in the form of a tree. Indirect recursion. Indirect recursion. A calling A, that is called recursion. A calling B. A calling B. See this one. A calling B. B calling A. B calling A. It's an interesting problem. This one you can expect in the exam. This one you can expect in the exam. Please be careful. A calling B, B calling A. This one you can expect in the exam. It is going to be tricky problem. It is going to be tricky problem. Please careful. So this is the one example. Assume that I started with B of 5. See, B people are calling A people. Now A people calling B people. Alternative. B people calling A people. So like that. It looked like very danger, but it's exact like previous problem only. Previous problem, first level A, second level A, third level A, every level A. But here, first level B, second level A is. B means execute B code here. A means execute A code. B means execute B code. A means execute A code. Exactly same thing whatever you done previous. And one more. While doing this, You may waste lot of time if you do the same thing again. So can you see this? Can you see this one? B of 2 here. B of 2 this. Same B of 2. You no need to do again and again. This is called dynamic programming. Do one time. If any repetition is there, do one time. Repetition there, do one time. No repetition, continue. Same story like above. But remember, indirect recursion, maybe you can expect. Indirect recursion, mostly expect. Either non-tail or indirect recursion, you can expect. Next one, nested recursion, occurrence. Occurrence recurrence relation. Occurrence recurrence relation, something like this. It's exactly like this, exactly like this. They will give some value. See, they will give something like A of 0, 5, how much? He will ask you. So you have to do properly. Next one, A of 2, 3, how much? He will ask you. You have to give. A of 3, 5 is how much? Right? Remember, if it is occurrence, what is the meaning of nested recursion? Inside recursion, again they can see A calling A recursion, but inside A there. That is called nested recursion. If nested recursion, exactly like this is the occurrence recurrence relation. Exactly, no change at all. Right? Some shortcuts are there. For smaller n value, actually for the total may not be available. For smaller m value, there is a right notation. See, if m0, answer is n plus 1. m0, answer n plus 1. If m is 1, mn, remember, mn. If m0, answer is n plus 1. This is 6. You check once. Otherwise, normal way expand, you will get the same answer. If m is 1, a 1 comma 7. If m is 1, mn. M, right? So answer is n plus 2. 7 plus 2. Right? Careful now. If at all m value 2, a 2 9, then answer is going to be a 2 9. Answer is going to be right. So 2 into 9. Just multiply this. Plus 3 you do. 2 into 9, 8, 18, 2, 9, right? 2, 9, 18 plus 3, 21. So similar. So for a smaller m value, there are some shortcuts used. But remember, recurrence relation should be as it is. Suppose m value 3, a 3 comma 5, assume. Then answer is 2 power, whatever m value, n value, right? 2 power n value 5, 5 plus 3, minus 3. This is the formula. 2 power n plus 3, 2 power n plus 3 minus 3. So if at all m value 3, this is the story. Right? So right, these shortcuts, please remember, I given examples also. M value is 1, answer is n plus 2. M value 2, answer is 2 into n, right? 2 into n plus 2, so, right? Plus 3, 2n plus 3. Same recurrence relation, then only. If recurrence relation changes, you have to do manually. A 3, 7, right? So 2 power n plus 3, n value 7 plus 3, minus 3. 2 power 10 is 1024, minus 3, 1021, right? So please take care of this also. Yeah. Next one, static variable. Static variable, I think I want to give one more problem on static variable, so I written. Static variable and recursion. So static variable and recursion. See, fun1 calling fun1. Static variable is a combination, guarantee will come. So this problem also you do, it's a very, very important one. So 30 problems, sorry, 30 is the answer. Please verify. If I do that, it may take more time. It's one of the very good problem. Please, can you practice it? Can you practice it? It's a very, very important one. Can you practice it? This is going to come in the exam. Please practice it. It's a very, very important one. Answer is 30. Please check once. If anything wrong, please let me know in the comment section. Next one, right? This problem also. See everyone here, recursion. I want to say recursive programs will come in the exam. F calling F, n is equal to 0, return 0. Otherwise, even number, right? So n modulo 2. Small twist is there, please verify. Small twist is there, please verify in this problem. Small twist. You may do small mistake here. What is the small mistake? Assume that n value 50. K value 7, some number, 57. N is 0, no, come here. 50 modulo 2. Yes, 50 modulo 2 is a remainder. If 0 failed, if 0, remainder, right? 50 modulo 2 means, modulo means remainder, na? Remainder 0. Yes, if 0 fail, you will come here. Even number, you will come here. Odd number, you will go here. Please be careful. This is the only mistake what you can expect. Recursive program guarantee will come in the exam with small twist. Please verify this. Please verify this. See this one. For printf percentage d f of 20 comma 1. Right? Verify, answer is 5. Recursion, answer is 5. Verify. If I keep on doing, we never end this. We never end this particular course. Right? So I given one example. Answer also given 5. Please verify. Next one. Unsigned integer. So please see this one. This also similar. This also similar, right? Printf foo 513 comma 2. 513 comma 2. I want to say that recursive programs will come in the exam. Recursive program return n modulo r plus 4. F calling, right? So F calling F recursion. Please verify properly. This is 9. This is a recursive program. Please verify. Please verify this. And one more problem I given. This is also something related to recursion. So f of 173 I called. F function I called f of 173. So 173. N value less than or equal to 1, return this. Otherwise, f of n by 2, print this. Print this. Yeah, brackets. I think that's it. This also recursive program. Please verify. Please verify. Answer is going to be this one. Answer is going to be this one. Please verify. If any small wrong is there, if anything wrong, please let me know. I will verify. I will re-verify. I checked carefully, but it's a very big document. There may be chance of 1 or 2 small mistakes, right? Please, if any small mistake is there, please let me know. Now come here. Complex C declarations. Complex C declarations. Let me come here. Now, if you are comfortable till now, if you are comfortable before complex C declarations, if you are comfortable before, right, before complex C declaration, please comment in the comment section, sir, I am comfortable. If you say that, sir, in the complex C declaration, right, I am comfortable, sir, please comment in the comment section. Just comment in the comment section, sir, I am until complex C declaration, I am comfortable, sir. If you are comfortable till now, please comment. Please comment, I am comfortable. Right, let's move to complex C declaration, right? So int a of 5, int a of 5 means a is a array which contain 5 elements. A is a array which contain 5 elements. Int a of 5, a is a array which contain 5 integer pointer variables. See, diagrams are like this. A is a array which contain 5 slots. Int star a of 5, inside a 5 integer pointers are there. See, pointer to integer, pointer to integer, pointer to integer. But here if you observe 5 integers, that's it. Directly integer directly here. Integer directly here in the first diagram, integer directly here. But in the next case, pointer is there. If I go there, integer. If I go to one place, then I will get the integer. In the first one, directly I will get integer. But here, after one position, I will get integer. First, I will get the addresses. Now, if you see here, it look like same. This one look like similar. Both are look like similar. Both are look like similar. But here is, right, A is a pointer. It is not array. A is a pointer pointing to an array which contain 5 people. Right? Now let's see one interesting story here. Let's see. Because of these all are addresses, na? Assume it is 1,000. These all are addresses. See, addresses. These all are addresses. A means address. When I say here, right? When I say here, A plus, A is 1,000, A plus 1 means, right, one slot will increase. A is 1,000 because of everyone is 8 bytes, na? Plus 1, 1,008. But here, A is a pointer pointing to an array which contain 5 integers. 5 integers means everyone is 2 bytes. When I say right? A plus 1. When I say A plus 1, 5 people will skip. This total will skip. It's 1010. Please be careful. But here, if I observe here, A plus 1, right? Because of all our elements, 2 bytes, 1002. That is the difference between all of them. There is some difference. There is some difference. Please remember. Here, array of pointer plus 1, one pointer will skip. Here, array of integer, one integer will skip. But here, A is a pointer to 5 elements array plus 1, 5 element will skip. So be careful. Be careful. Same story here. Same story here, right? See, A is a pointer. But remember, A is a pointer pointing to one array. A is a one pointer pointing to one array which contain integer double pointer, means pointers, which contain pointers, double pointer. Remember, double pointer means what? Right? Address, if here address there, if I go there, again address there, double pointer. So A is a pointer pointing to an array which contain 5 slots. Right? A is a pointer pointing to an array which contain 5 slots, where everyone is a double pointer. Remember, everyone is a double pointer. Here 8 byte, 8 byte, 8 byte, 8 byte, 8 bytes. When I say A plus 1, 5 8s, 1040, something like that. It is A is a pointer to an array which contain 5 people. When I say plus 1, next 5 people will come. Here everyone is 8 bytes. 5 8s, 40. Perfect. Now see carefully this. See carefully this. See carefully this one. Because of lack of bracket, na, x. X is a function. See, x is a function. X is lack of bracket. X will go with the first bracket. X is a function which will take 2 parameters as input, integer, float. But finally, this function return pointer. That pointer pointing to an array, right? Where that array contain everyone is a pointer. That pointer pointing to a function which don't take anything, finally return character. Same thing there. See, x is a function taking 2 parameter, int and float, and that function finally returning a pointer, right? And that pointer pointing to an array which finally return an array where everyone is a pointer, right? Finally that particular array contain pointers where every pointer pointing to a function which finally return character. So I try to visualize also in the form of a diagram. Please verify. A is A, right? So let's check here. What is the answer? I written here. X is a function. See, x is a function which will take 2 parameter, which will return finally, which will return one pointer. Finally, this function returning a one pointer. Assume that pointer is this, right? This pointer pointing to an array which contain pointers. Where if you go to that pointer, right? If you go to that pointer pointing to a function which will finally return character. Try to visualize also. Please check one time. Please check one time. Same way here also. One more. Right? One more. See this. I think if you observe clearly, B. I think here onwards you can start. Here. So B is a function which will take 2 parameter. 2 parameter may be costly, look like difficult, but 2 parameter. B is a function which will take 2 parameter. This is the first parameter, second parameter, read properly. Finally, this function returning a pointer. That pointer pointing to a function which will take integer, which will return void. Same thing. Which will return finally nothing. Verify one time. Now, so careful, call by value, call by reference. Careful about call by value, call by reference. Call by reference. Call by value, originals will not affect. Call by reference, originals will affect. Call by reference also, I written some story, you can refer once. Can you read this entire story once? Right? One example also I given. Call by reference. Call by reference. See, these are the originals. These are the originals. Lastly, originals are affected. So before calling, after calling, I verified. Originals are affected. But call by value, originals will not affect. Before calling, 1020. After calling also 1020. Originals, if you want to effect. Originals, you want to change reference. Originals, you don't want to change value. One previous year problem. This is one previous year problem. Please check properly. See, this is by call by reference. This is by call by value. He asked in one of the examination, in this program, swap function passing two parameter, one parameter by address, one parameter by value. So right, this is the effect. One will update, one will not update. Anyhow, one printf only there. Answer 2020 check. Right, now see the miscellaneous. Some more important points. Post incrementation, please careful. In exam, it may affect. Yeah, fine. Now come here. Come here now, post incrementation. In examination, this may affect. What post incrementation? Please take care properly. What is the post incrementation? Simple. If a, right, x is equal to 10, right? If x is equal to 10, if you done x plus plus, it is the 10 plus plus is 10 only. So a is 10, but after that line over, x became 11. At that time, post incrementation will not affect. At that time itself pre-incrementation will affect. Please take care difference between post and pre, because most probably you will do this mistake in the exam. Next one, shorthand operator. Remember, a is equal to a plus b means a plus b should be done. Let's see this one. A plus is equal to b means a is equal to a plus b. That is okay. A star is equal to b plus c means a is equal to a star b plus. But remember, right should be done first. So bracket required. This is the most probable mistake people will do. Shorthand operator, people will do mistake. See, a plus is equal to some big expression. So, let me repeat once again. A plus is equal to some big expression. If I write, assume some x. Then while writing this one, a is equal to a plus, you keep bracket, because this may be very big expression. It will affect. So be careful. This is the only mistake what you can do. Shorthand operand, right? It may kill you if you do small mistake. Short circuit. Short circuit means after some point you got to know. After some point you got to know there is no use of. Suppose assume that one end something. One end. I think end operator both should be true, na? Even though it is true, you have to go further. Here short end I cannot do anything. But zero end anything. So here no need to go. Zero end itself is fail, which is zero. Right? So see the example. See the example. See the example here. Right? End operation means this one. R operation means this one. Right? See, here observe this. End operation going on. If this itself is zero, you no need to go further. If this is one, then only go further. Based on that, this problem is given. Please verify. Please verify this problem. Right? On the short circuit. Right? This is the short circuit. Short circuit. On the short circuit, one problem is given. Please verify. This is a problem. Please verify. So first printed 4, next printed 7, next printed 10, next printed 13. Please verify. It's a very, very interesting problem to understand the short circuit. It may come in the exam. Next one, switch case. Also you can expect some questions in the exam. Switch case, right? This also, can you practice it? Switch case. So most probably you can expect one question on the switch case. I arranged some problems here. Please try. Please try this switch case. Finally, right? If you see the output of this program, right? I think so many values may be printed. Please see the output properly. Right? You have to execute once. I written the code also. I written the explanation also. You can check once. Similarly, switch case main important points also I written. You have to read all of them. And remember everyone, notes is provided below. Right? In the comment section or description, you can see that. These all are the switch case. These all are the switch case points. These all are the switch case points. Anywhere doubt there, please let me know. Switch case problem given. Switch case problem is given. Explanation also given. Some theory also I written here. You can go through it. Right. Now one more problem I given about switch case. One more problem I given. Can you see this? One more problem I given about the switch case. Right? Check one time. Next one, continue keyword. And about continue keyword also, normally continue will be there in the loop. Right? Continue keyword also something I written and I given some example also. Can you check? Can you check this? So it may print, right? Verify yourself. It may print 5, I think. Output is 5. Verify. Anyhow, you can verify. Anyhow, you can verify. Output is 5. You check. Next one, left shift up. Left shift means multiply by 2. Right shift means divide by 2. So this is when you say left shift, just 1 0 added on the right side, so that all will be multiplied by 2. So right shift, right? This is the left shift. Left shift means I think 2 less thans. Right? Right shift, if you see, right, 1 bit will be deleted. Right? So I think if you observe clearly, all people go one position right. All people will go one position right. What I think here total how many bits are there? 6 bits. 6 bits after completion of this. Right? So this will go here. This will go here. Right? This will go here. This will go here. This will go here. This last person. Right, will go back to previous. This last person will go back. Otherwise, this person you can ignore. Last person you can ignore. 1 bit will decrease. LSB bit lost. This bit will be lost. Right? If you keep 0 also no problem. Right? This when you say those people who confused. Right? It is a right shift. Sorry for this. I will change it to the right shift. It is a right shift. Previously 6 bits are there. Now 5 bits. LSB bit delete. 1 0 1 0 1 0. After doing the right shift, all will shift like this. Last bit delete. Right shift means 1 bit you lose. That is divide by 2. Very simple. Left shift multiply by 2. Right shift is divide by 2. We check properly. Next one, odd even checking. That is very simple. There is a one binary number. How to check it is a even or odd? Right? What you do is simply that number do end operation with 1. So one number is there. I done end operation with 1. In the remainder, if in the result, if you see, right, it's the result. Same one more number, do end operation with 1. You got this. So finally, result is assume A. If A is equal to 1, then the number is odd. Otherwise, right? Otherwise, it is even. Otherwise, it is the even number. Do end operation with the 1. If the result is 1, then odd. Otherwise, 0. Right? Nothing is there. Yeah, this is not that much important. But anyhow, I covered this point. Checking even number, odd number. How to check a particular number is even number or odd number? Just to do operation, any number, end operation with 1. Result is 1, it's odd number, otherwise even number. Right? This is the way how computer will verify. Right? Perfect. I hope you people got it. This is the C programming revision notes or short notes. Use it properly. Any doubts are there, comment in the comment section. Right? Any point you liked it, please write in the comment section. I liked it. Right? I hope this will be useful to you. Right? So, and one more thing is notes also provided. Link is given in the description and the first comment also. See the first comment or description, you will see the notes also. Thank you so much and I wish you all the best.